Well, YouTube, we have another unboxing. This is a used item from eBay. So let's break open the K-bar and see what's in it. This is kind of a bigger box, so I'm going to open it off camera and we'll pull out the contents. So very nicely packaged was this. A isolated variable transformer. Let's take a closer look. So here we can see it's a BK Precision 1655A. The newer of the two versions, as you can see in the back in this corner, I have another one. It's the older version. It's the 1655. So we'll pull that one out and compare the two. Unfortunately, my older one arrived damaged. This gauge here was busted and unrepairable. So let's start by powering this one up, testing it, and we'll see if we receive a good unit this time. Okay, since it's always a good idea. All right then, because it's always a good idea to take apart an AC test, a piece of surplus test equipment, I'm gonna do the next best thing. Prior to just giving this 120 volts and just hoping everything's okay and not burning anything up, what we're gonna go ahead and do is I've got it plugged into the old isolation transformer that I have. The gauge doesn't work, but the rest of it works and has been tested, works well. So what I'm going to do here is go ahead and power on the new unit, and then you can see with the Agilent 34401A, we'll monitor the AC voltage as we turn it up. And you can see that light starting to illuminate, saying it's on. You don't smell anything or hear anything. That's good. That red light's growing brightly. Hear a little bit of a hum as we hit 120. Yeah, I hear a little bit of a hum. So worst case, I can switch the internals from one to the other. But we'll see. We'll dive into that. All right. So let's see. Oh. Well, let's turn on the second Hewlett-Packard 34401A. I'm going to hook up some test leads and we'll measure the output voltage, see what the Agilent thinks about the gauge on this one. I'm not quite sure that it's going to be perfect. It's not quite going back to zero either. I don't know. We'll dive into that. Okay. All right. So we have that second voltmeter plugged in to this device under test isolator, and we'll slowly bring up the voltage. Let's go to 30 volts on the machine. Not too bad. Agilent's reading 26. Go up to 50. Overshot a bit. Let's see what, about 50. Okay, 44. So, we're not quite linear, but 70, 61, yeah. So interesting. Where it should be calibrated probably, and should be the most accurate, would be 120. Since that's where all the printed on, screened on test measurements for currently, or for voltage leakage and amperage use on the gauge of the meter. Okay. And it says we're only putting out 104 at 120. We don't hit 120 until close to 140. So let's see if we can get the full 150 out of this. Okay, yeah, there we go. We can actually get 160. Interesting. Interesting, because I think the other one, it only puts out one. Oh, no, it hits almost 160. Drop it back down to 120. Right there. Okay. So it appears this gauge is off. So let's set it at 120. We'll try adjusting it. Okay, I adjusted the gauge on it the best I could. That's as close as I can get the gauge of it to 120. You see we're 125-ish. But we're dead on 120 voltage coming out. Let's drop it back down to 80. See what 80 reads. 78. So that's pretty darn close right there. 50. 51. Okay, so we're bang on the lower scales. Drop it down to 20. Now, let me look at it without parallax. Look at it straight on. We're right at 20. 22. So that's not too bad. Let's see where we start to lose that accuracy. Go up to 90. 87. You know, ballpark-ish. 100. 95. Getting further off. 110. 105. Now it's definitely linearly, or not linearly, it's getting off by a percentage though. So I guess that would be linearly. 120, we're only at 115. Or well, 114 technically. And oh well, there's a little bit of parallax. Let me adjust it up a bit. So that's bang on 120 on the gauge. Still 114. So I'm not sure how much that percentage of error off affects the calibration, but let me find another load to plug into this, and we'll test amperage and go from there. Test the leak and the hot and common leakage of something. Okay. Okay, so I discovered some problems now that I plugged it directly into mains. Now that we know it can take 120, I unplugged it from the other variable transformer and plugged it into mains direct. And then I'll show you right now we're set to volts. I'll show you what the issue is. Up until about 30 on this gauge here, we're about 5 volts off. Then when I turn this up to 120, we hit 150. So that's going to be a problem using the leakage detector, the leakage probe, and I'm not sure about the amps, because let me show you what the amps are doing. Okay, now that looks like 0 from your point of view. Let's see if you can see it move. I see it move. I don't know if you guys do, but I see it move. And as you can see on the meter, we're only drawing a little over 1/10 of an amp. So that really corresponds to about what that gauge might be moving, because 1 amp would be way up here. So one thing I can show you is, let's go to the hot, and I have this Agilent that I've been going through, another 34401A, and let me ground this tip to the chassis, and you'll see this needle move a little bit, and that's indicating leakage. We're on hot right now. So on the hot line, basically the black wire, you see it move ever so slightly. Now, unfortunately, because this is off when we have it set to 120, it reads up to 150. So when we have it set at 120, that corresponds to this green scale here. All right. And so for this green scale to be accurate, we would have to have it set to 120. But the amount that needle moves when we do the hot is it's not conclusive, because I don't know. I haven't determined what's off on the gauge yet. But that's not a lot of movement, because if you see how much movement down here, basically your leakage is this graph down here, and this green here should correspond to it. And maybe that's accurate still, even with the voltage up. I don't know, but it doesn't even move hardly at all, so that's good. But let's go to the common, which I assume is the neutral or the white wire. I get this touching. Yeah, there's virtually no leakage. You see it moving ever so slightly. Ever so slightly. Go back to hot. Okay. Interesting. We're getting more out of the hot now. We're still only at an acceptable, very acceptable range of 100 microamps. So virtually nothing. Interesting. Maybe this needs cleaned up. Maybe there's something going on in the switch of this new guy. Let's try this. Let's try powering it back on. Yeah, I don't know. It's still acting kind of funky. We'll need to investigate it on the inside. So yeah, unfortunately there's still something going on with the gauge of this one. Okay. Yeah. The common, there's virtually no leakage. Maybe that's how you're supposed to do it. Maybe you're supposed to push the button in after you make contact. I'm not sure. Have to read the manual. But still, it's saying here on this gauge 500 microamps. You'd have to look at the specifications of the equipment you're testing. But I mean 100 microamps is virtually nothing. If that's accurate. We'll have to see. Again, going back to the amps, let me get something in here that'll actually draw some current, and we'll see what the adjutant thinks about the amperage gauge on the BK Precision. Okay, so now what I've done is I've chosen to hook up a bunch of devices together to test this tester out. Well, okay, so this is what we're doing. We've got this plugged into mains. This is plugged into the isolated transformer. This is one of my old retired power supplies. We can do up about almost 10 amps out of it. So we'll try to draw some more current through this, right? Because as you see the needle move, but we're drawing just over 1/10 of an amp. So that possibly corresponds to that little bit that you see there. So we'll go ahead and turn on this. Oh, and then I have a DC load plugged into this power supply. So the DC load will be drawing power from the power supply. The power supply will be drawing power from the isolated transformer. So thereby we'll be pulling current through the isolated transformer. So let's go ahead and flip it on. Watch that needle climb. Now, as you see, I've already got it set on this end. I've got it set to only about 7 amps. You know, that gauge isn't accurate really on that load per se, but I've got it set to about 7 amps draw here. And this has hit the constant current already. Either way. Oh yeah, it's because I've got the current turned down. I turned the current down on this so this would draw less through this, so that we're only reading 1 amp exactly on the scale here. And looking at it, well, there's a bit of parallax. So let me look straight on. All right. So correcting that parallax, we're at exactly 1 amp on the amp scale. And we're reading 1.1 amps. I don't know. I call that pretty dead on right there. Let's go to the 0 to 2 amp scale. Yeah, so there's something funky going on. Well, you know, and especially AC amperage gauges, they're not highly accurate per se. But on the 1 through 4, it's accurate, but we try to get that higher resolution. Now we're down a little bit. So it's still acting funky. It works a hell of a lot better than the other one that has a broken gauge, but not much better, but at least I see the gauge move. That makes me feel better, I guess. But yeah, we're drawing an amp of AC through this. As we see on there, we're reading close to 2 amps. Let's drop that current down. See if that affects our reading. Okay, so we turn the current all the way off. Let's See if we can get it to read. Or am I looking at the wrong scale here? I'm a dummy. I'm dumb. This scale is for the 0 to 4 amp button that I was pushing. This scale down here is for the 0 to 2. So it was reading correct. Let me now move it up to the... well, apparently everybody's going to know I'm an idiot because I'm going to post this. Okay, so now that we're on a 1 amp on this scale for this, we switch back to 2. Okay, so we're off a little bit. But, I mean, that's close enough. So, I believe the amperage gauge is working correct. It's just the voltage portion. Again, let's go to the hot leak. Let's check that on this. Now there's a little bit of paint. See if I can get to a spot. Let's screw right here. On the side is what I'm probing on. Okay. So here we see a leakage current. Again, almost 100 microamps on the hot. On the common, oops. It's almost null. It's almost non-existent. I mean, it's probably in the tens of microamps. Okay, so that makes me feel better. Those amperage gauges are more or less working. And there's something funky going on. Like I said, it's amperage AC gauges are finicky anyways. See, and now we read some, we'll take this apart. We'll look inside. First, we're going to compare it to the... Well, no, we'll take it apart first. And we'll take a look inside. Then we'll compare it to the old one. See the differences. I like this new one a lot better. It looks much nicer. And the gauge is partially working, so that's a good deal right there. Now let's crank this all the way up to draw some... Oh yeah, it doesn't do anything. Well, yeah, it does. No, it doesn't, because that's a slave. Duh. Okay, so like I said, we don't get quite 10 amps. And that gauge isn't accurate on the load, and we don't get quite 10 amps through this DC. But as you see, we're drawing maybe 1.25 amps on the 0 to 4. The higher resolution, again, it agrees. It agrees we're about 1.25 amps. We look at the adjuvant, 1 3/10. I call that bang on close to, well, not bang on, but I call that pretty damn close to, I call those pretty close. The amperage gauge is definitely working. So despite what I said, it's kind of finicky there as we switch it. But for the most part, once you get a good reading out of it, I mean, we're spot on. That's bang on, pretty much. The amperages. It's just the voltage isn't working. And because this voltage isn't working correct, I assume... Well, no, actually, the leakage should be working correct as well. The leakage should be working correct because this guy doesn't know that the gauge is off. So the only thing that's off is a 120. Is AC voltage coming out of this. That's the only thing that's off. I think as far as our leakage, I think that's bang on too. I mean, we're all of maybe 20 20 microamps maybe. All right, on the common. I'm pretty sure that's the neutral is what they mean. And then on the hot, I mean, actually we're less. We're maybe 90 microamps. We're less than 100. So, I'm going to call that working too. I think our only issue is our AC coming out. Maybe there's something okay. And now look at that. Maybe there's something going on with these switches. Maybe these switches need cleaned, because now look at that. Now we're almost reading 120. Oh no, we're reading 120 bang on. And we've only got 111 coming out because there's a load on it. Let's turn this load off. Okay, we went up to 118 actual. Yeah, you know, I mean, that makes me feel a little bit better. Maybe there's something funky going on. Maybe the contacts in these switches, there's something going on in there. I've got hope for this still. This is definitely a much nicer unit than the old one I received. And again, if there is something wrong with this gauge, this one's no part the fault of the seller. I mean, it was packaged very well. I don't think it got damaged in shipping. You know, it was untested, the whole untested off Amazon bull crap. But the other one was shown working on Amazon, and because it was packaged poorly, it was damaged. And it is what it is, but we've got an almost working unit here, and so like I said, we'll get it cleaned up, and nothing's cooperating today. Hold on a second, we're over voltage. I should adjust that real quick. But interesting, my modification of this, I see the ground might still be linked. Plug the hot that I'm sensing, and we'll adjust our voltage, adjust it down to 12 because we're trying to pull 14, so it won't be over anymore. What's going on there? Regardless, I was not here for the load. Load's not my issue. I'm obviously having some issues with operating my own equipment, but I'm saying stupid stuff. But let's get the bench cleared off, get all these wires put away, and we'll go ahead and open up this, unhook it from mains, obviously, and we'll open up this BK Precision. We'll inspect it. So here in a second, we'll be back for that. Okay, so looking inside of it, it actually looks really nice. This definitely wasn't from a humid environment, as we can see from that transformer right here. This transformer, the isolation transformer, looks very, very clean, no rust. The variable transformer, it also looks much nicer than my other one does. But yeah, I mean, overall, this looks great inside. It needs cleaned up, get it vacuumed out, and we'll look at that board and those switches. See, kind of give that a good inspection. We'll pull it from the unit, give it a good inspection, and hopefully that'll solve the issue with the gauge. I don't know. And originally I thought the gauge wouldn't know. So there's probably something going on this board, because there's only 2 wires going to the gauge. I assumed there was going to be at least 4, probably 6 or 7, maybe 8. But apparently this board is telling the gauge what to do. So although the board looks fine, you know, I don't see any electrolytic capacitors, but another component could be bad. Yeah, we'll go ahead and get her cleaned up. Show you guys the difference between the two, the new versus the old model. And then I'm gonna get her cleaned up and see how it does. Okay, so some of the basic differences I see a lot, obviously. It's basically from a 1970s era to 1980s, 90-ish era in the design and the look of the unit. All right, so the gauge noticeably smaller. It's just more attractive, the newer one. The knobs are different. The power switch, the indicator lights are much better. The probe is so much nicer. You know, this one is definitely a PVC plastic jacket. This kind of cheap looking probe, and I assume what's going on inside here. Oh yeah, what you're doing is actually moving. So this switch is isolated until you move that, or this tip is isolated, and you must be physically moving something inside there to touch. Whereas this probe is much nicer. This definitely feels like a silicone jacket. It's much nicer, much more flexible, just looks better even. But this one, you push this button in here, and then you pull back this, well, push it in, not pull back, you push it in, and it exposes the tip so that you don't accidentally shock yourself, which is kind of hard to do with an isolation transformer, because by definition we're galvanically, something like that, isolated from earth ground, right? We don't have that earth ground reference on an isolated transformer, so technically it's there so you don't shock yourself or you don't blow up your oscilloscope, but you know, you still don't want to be touching 120, 150 volts. Yeah, I have, and you don't feel anything. It's not like when you touch something coming out of mains and you feel that tingling of being electrocuted, or being shocked, not electrocuted, of being shocked. You know, you don't feel anything with the isolation transformer. Now, if you were to touch both sides of the circuit, I think you'd probably get a jolt, and there's potential for it to feed back through ground, and you know, there's lots of variables. The adjustment screw is a little bit different. This one's flush. This one was recessed. Yeah, when I arrived, the gauge was all pushed in, and the gauge, as you see, it's not even reading zero now. The gauge doesn't work, period. It's completely physically broken. I like this power switch better. Rocker instead of a toggle, or rocker instead of a toggle. Knobs are much nicer. They feel nicer. They're a lot higher quality. And like I said, those indicator lights look so much better. You can actually see them. So basically, I showed you guys the buttons and what those do, how they change the gauge, and you do your leakage current, or your leakage current test, or measure your amperage going out of the isolation. And then this one is obviously we adjust our voltage from 0 to apparently 160 volts, even though the gauge only goes up to 150. And then this one right here, we're not plugged in because I still got the top off, but there's a receptacle on the back that I'll show you. The receptacle's independent of these. These go through not only the isolation transformer, but through the variable transformer, these two. and these two are wired together. One says 3 amps continuous, the other one says 4 amps intermittent above it. That's a little bit misleading. They both are 4 amps intermittent and 3 amps continuous, right? So, but this, I don't believe it, well, it doesn't go through the variable transformer. I believe it does go through the isolation. I haven't followed the circuit in a while, but, so this would go through the isolation, then it goes to the back, and you can control the voltage to your soldering iron. All right, and I'll show you that receptacle when we look at the back side. Another thing that's different is the carry handle. The actual case, the physical construction of the unit. Yeah, see, not putting it back on right now. I gotta clean it up. But it's got the carry handle on top, which I don't really need, but it'll just go back in the rack. But you can see the construction's completely different. The chassis is different on it. I mean, the unit's overall a little bit slimmer, a little bit shorter, and I don't know, we'll look at the measurements, and I'll look at that once I get it back together and see how much different it is. But let's take a look at the back. All right, so as we can see, like I said, the chassis is much different. It's been completely redesigned on the A model. Other than that, we have the same components in the same locations again. A little bit different components. We got our fuse holder for if you actually do, if there's an internal fault, actually, if there's an internal fault in the system, that fuse will blow before you do, hopefully, too much damage. But the fuse holder's different. All right, and then the circuit breaker. What the circuit breaker does is on your variable transformer side, I'm not sure if it works on soldering iron too, but on the variable isolated transformer side of it, if you draw more than your 4 amps for your allotted time, you know, more than 3 amps or more than 4 for an allotted time, this is going to trip. I'm not sure what it's rated at, whether it's 4 or 3, whatever. That's irrelevant. It just, probably if you're over 3 for a long time, it should trip. And like I said, anything over intermittent 4 should trip. So I don't know the specs on it. Not even going to pretend to. But we see that's been redesigned. The new design's much nicer. Receptacle's a bit different. But this is the receptacle I was talking about for the variable voltage on the soldering iron. And like I said, that doesn't go through the variable transformer. I looked at the wiring. It's actually different. It's a different system. I'm not sure exactly what technique they're using for whether it's another variable transformer or they're using another method to regulate that AC voltage. But yeah, all in all, happy so far. Still got to get it cleaned up, and we'll see if those switches work better. That'll probably be for another video. All right, so like I said, cleanup and retest is for another video. But there it is in its final home. It's quite a bit small. I should have measured it too, but I'll do that at a later date. It's quite a bit shorter, narrower, possibly shorter in length, but I'm not 100% sure on that. But it's definitely shorter in height and less in width. So I don't know. I think this will bring me some good service once I get it cleaned out and operating correctly. All right. So like I stated, this originally came with a damaged gauge. All right, so the plastic was all busted up, and you can't really tell, but this needle is actually off the deal. in there. I tried to put it back on. Sometimes you can do that, but yeah, see, it's not in where it's supposed to be. So the gauge didn't work, so it was kind of useless for my purposes, other than an isolated variable transformer. So it still has some use. My original thought, what I was going to do is take these two gauges and make a bracket and put my amperage output and my voltage output down here with two separate wires. I was going to rewire it and do it that way, but that was before I saw this deal online and got, you know, a $500-600 variable transformer for two. So, you know, I think I even paid less for the newer AIM model, which goes for way more than I did for the 1655. So all in all, I'm happy, and I think it's gonna work good for me. This old one, I don't know, I'm either gonna resell it for parts, or use it for parts. You know, there's a lot of good parts on it still. The chassis, those transformers. Maybe I'll make something out of that. Maybe I'll just sell it. Like I said, getting the gauge, and I even tried to call BK Precision. Like you see, the new gauge, even if they'd have sent me one, the new gauge is nowhere near the same as the old. So it wouldn't have fit anyway. So, nah, the fact that they blew me off doesn't matter at this point. So, that's about all I got. Thanks.